Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to take a look at Section 1, Rational Exponents of our Exponents unit. So rational exponents are basically a fancy way of saying that we have an exponent written as a fraction. When you have exponents written as fractions, those fraction exponents can be rewritten as a radical, a square root, a cube root, or any root of a higher index. So what we want to do is learn how to convert back and forth between the two forms. So when you're given a rational exponent, to make it a radical, you would take the denominator of the fraction and make it your index. That tells you what type of root you're finding. And you would take the numerator of the fraction and make it your exponent on the inside. So a to the 1 over n would be the nth root of a. To reverse that process, we would just need to take the radical, make the index, or what type of root we have, the denominator, and the exponent on the inside, a fraction. So let's take a look at a couple different examples. So in problem 1, we're going to rewrite our radicals as simplified exponents. So the square root of 7. The square root of 7, what I would do is first take the number I'm working with, 7. That is my base. And then I need to write what exponential fraction goes with it, or what rational exponent goes with it. So the numerator of my fraction is the exponent on the 7. In this case, it's a 1. And the denominator is the type of root I was finding. This one was a square root, so my denominator is 2. So the square root of 7 could also be written as 7 to the 1/2. Since I cannot simplify the fraction 1/2, this is my final answer. And number 2, we have the cube root of 6 to the 4th power. In order to write this one, what I want to do is first identify my base. What number am I working with? In this case, it's 6. And then write my fraction associated with it. The exponent is the numerator. In this case, there's a 4 with the 6. The type of root I'm finding is the denominator. In this case, I'm finding a cube root. So the denominator would be 4/3. Since I cannot simplify the fraction 4/3, I would leave this as 6 to the 4/3 power. And number 3, the square root of 8 to the 3rd. First thing I want to do is identify my base. This one's an 8. I'm working with 8. And then write my exponent as a fraction. The exponent on the 8 is the numerator, in this case 3, and the type of root I'm finding is the denominator. In this case, a square root, so it's 2. So this would be 8 to the 3/2, and since I cannot simplify 3/2, it is going to stay 8 to the 3/2. In problem 2, we're going to reverse what we just did in problem 1 and rewrite the rational exponents as simplified radicals. So in the first one, I have 3 to the 1/2 power. So first thing I'm going to do when I rewrite as a radical is draw the radical symbol. The number on the index is the denominator of the fraction. In this case, it's a 2. Now remember, 2's mean square roots. And when you see a square root, you never see the 2 written on the index. So I will not write a 2. I would just draw the square root symbol. My base is 3. That goes on the inside. And my exponent would be the numerator of the fraction, in this case 1. Now, you also never see exponents of 1 written, so this would just be the square root of 3. Now, anytime you have square roots or cube roots, you do want to simplify them if it can be simplified. The square root of 3 is not a perfect square, so that would be my final answer. For number 2, we have 8 to the 2/3 power. So the first thing I'm going to do is rewrite this. So I start by drawing my radical symbol. The denominator of the fraction is my root. In this case, it's a 3, so I'm finding a cube root. And then 8 is my base, and my exponent is 2. Now, I want to simplify this. Now, instead of actually multiplying out 8 squared and then simplifying that big number, I'm going to use my math facts. I know that 8 squared means 8 times 8. And I know that 8 can be broken down to 2 and 4, and 4 can be broken down to 2 and 2. So since I'm finding a cube root, I'm looking for 3 of the same numbers. This one 8 broke down to 3 2s, which means my other 8 is going to break down to 3 2s. So the cube root of 8 squared, I have 2 groups of 2 circled. That means it's a perfect cube because there was nothing left over. 2 times 2 is 4. So my final answer, 8 to the 2/3, the cube root of 8 squared, is the same thing as 4. So remember, square roots and cube roots, I want you to simplify those if it's possible. And number 1, we couldn't, and number 2, we could. Now let's take a look at our final example, number 3. We've got 125x to the 7th to the 2/3 power. So the first thing I'm going to do is rewrite this. This is a cube root because that's the denominator of my fraction. My base is 125x to the 7th. Notice I'm keeping it in parentheses. And then squared would be my exponent because it was the numerator of the fraction. Now this is a cube root, so I want to see if it simplifies. So again, I am not going to multiply this out. I am just going to use the exponents to my advantage. 125x to the 7th squared means I have 2 125x to the 7ths. So I can break down this small number. 125 is 5 and 25. And 25 is 5 and 5. So since I'm finding the cube root, I need 3 of the same number. So if that 125 broke down to 3 5, so will this one. And then I also need to break down those x's. So x to the 7th means I have 7 x's. There's 6, there's 7. So again, finding groups of 3's, because this is a cube root, I find there's 1 x left over. If this x to the 7th is 2 groups with 1 left over, so is the other one. So I'm really saving myself work just by doing 1 at a time and copying it back down. So if I take a look, if I write my final answer, everything I circled, 5x, x, 5x, x, needs to leave the radical, the cube root. I'm going to multiply all those together. 5 times 5 is 25. X times x times x times x would be x to how many groups did I have? The 4th. And then since I had 2 x's left over on the inside, I've got to keep that cube root symbol. And x times x would be x to the 2nd power. Remember, we're multiplying what's left, not adding it. So this would simplify to 25x to the 4th, the cube root of x squared. This concludes our lesson on being able to write rational exponents and convert rational exponents to radicals that are fully simplified. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.